Okay. Today's lecture will be an introduction to geotechnical engineering. Also, it will be the link between geotechnical engineering and geology, because our term, this term, we are going to study geology. So we need to understand what is the reason why are we studying geology. Are we studying geology because we need to be geologists? No, we are studying geology because we need to be geotechnical engineers. So what is the link between both? And what do we need from geology to be good geotechnical engineers? Well, first of all, you don't know what is geotechnical engineering. So geotechnical engineering is everything you do not see related to structures. What does this mean? If you look at this picture, you will find that this is a bridge, this is a building, this is a harbor. Here's some buildings, equipment, drilling, so on. This is what you usually see wherever you go at any site or even in any street. But is this the full picture? No, the full picture is this. This is the full picture. Below this bridge, there should be foundations. I cannot put the bridge directly on the soil. There should be something to transfer the load coming from the bridge to the soil. The soil is weak, and the load of the bridge is very high. How can I make something to carry this? So as we said, this is the full picture. Below the bridge, there is foundations. Below the building, there is a basement, and below the basement, there is also a foundation. Here, there is a tunnel. You did not see the tunnel above ground. It is fully below the ground. Below the harbor, there is piles, khawazid, as we say in Arabic. So these piles carry the load to the ground, or there is piles next to the interface with the chips. This is to carry the load and to carry horizontal load also, vertical plus horizontal load. There is here a shaft, and the people here below are working. They are doing something below ground. So the full picture is different from what you see on top of the ground. This is one thing. So what is different? The difference is that there is here there is soil. Okay. Is the soil here the same as the soil there?
No.
Soil is God's creation. And it is not composed of one material. You all know that there is sand and clay, at least these two components, you know, sand, raml, clay, tin. These two components are you have seen it in lots of places. But soil is a combination of these two plus others with different percentages. It's like food. If you do a recipe and every time you change part of the recipe, this you can judge, every time it will have a different taste. The same soil, every time you will find that in this building there is a type of soil, in the next building, and sometimes in the same building, but at different location, you have different types of soil. So soil is different. This is the problem. But if I tell you that here we are in this pile, we are using concrete, and in this pile we are using concrete, I can define both. If I say that I'm using concrete grade so and so, it means that I know the properties of this concrete. And in that other place, I use another grade of concrete. I know exactly the percentages of the constituents. I know the properties. I know everything. But in soil, you don't know anything. So it is a problem. It means that I may have a problem with the bridge, with the building, with the harbor, with anything, because I don't know what is the soil. So what can I do? Then I need to understand what is soil and how soil will interact with my structure. Okay, let's see what is the relation between this is the interaction between soil and structure. This is geotechnical engineering. So now we need to understand what is the relation between geotechnical engineering and geology, because we are not going to study this year geotechnical engineering. We are going to study geology. So let's see what is the difference or the relation between both. This is science. Science is divided into applied, natural, and social science. If we take the natural part of science, we'll find that natural science is divided into biological and physical. Take the physical part of science, you will find that physical part of natural science is divided into physics, chemistry, earth science, and astronomy. Of course, we need earth science because we are dealing with geotechnical engineering and geology. So earth science is divided into meteorology, geology, and hydrology. So this we don't need because it deals with something outside of our scope. But let's concentrate on these two, geology and hydrology. So now we reach geology. So geology as a science or as a part of science, plus another science which is hydrology. What is the difference between geology and hydrology? Geology, geo, means soil. So geology is the science of soil or the science of earth. Hydrology is the science of water, because if you dig a hole in the ground, you will find soil and you may find water. So we have a combination of soil and water. So if we study the science of soil, which is geology, and the science of water, which is hydrology, and combine them together, we are going to reach geotechnical engineering. So now you know what is the relation between both. But why geology, we call it science, and geotechnical, we call it engineering? Why don't we call it geotechnical science? Because it is not a science, it is an engineering. So we need to know what is the difference between science and engineering. Science, we all know that we know a lot of scientists. These scientists studied everything around us. These are called scientists. Scientists studies the world. They create questions. If you have a scientist, he will say that the earth is composed of so and so, it was created many millions years ago, but he will tell you that there is a problem. There is an earthquake that can happen. This is the end of the task of the scientist. But the engineer, what can he do? The engineer presents solutions. What does this mean? I live in Japan and I have lots of earthquakes. The geologist will tell me that you have an earthquake, the magnitude of the earthquake is so and so. That's the end of the task of the geologist. But the engineer will build buildings that can sustain the earthquake. So engineers or engineering, we present the solution for people to live safe. So this is why do we call it engineering and not and not science. So how can geotechnical engineers do this? They analyze the problem, design the structure or whatever they need to design, and construct this structure. Before we go into geology, we need to know what can happen if we do not study geotechnical engineering. I always try, before studying anything, to know the importance of what may happen if I do not study it. This is a very good way to appreciate what you are going to study, to appreciate the effort that you are going to exert to do this task. If you look at this picture, this is a road, and this is slope, high land. This is higher than the road. What happened? What happened is that the soil slided and covered, if you can see here, it covered the street. There may be cars that was passing by when this happened, and there may be people that were inside, and these people might have been injured or dead. So I need you to understand that you are doing something very important for your society. When you study something, when you study geotechnical engineering, you can save lives. It's exactly like the medical doctor. He saves life directly, but you saves life indirectly. You build stable structures, and these structures do not collapse. You avoid something like wind, strong winds, hurricanes, floods, slope failures like this. You can save the life of people. So you are doing something very important. So you have to give some effort. This is important. You are not just studying boring equations and lots of names and features and properties for soil. It's not for just to get some marks. No, it is to save lives. So this is an example. This is another example similar to this one. Also a slope, and there is buildings below this slope. There may be people that were sleeping in these buildings at the time that this happened. They were the soil covered their buildings. They may be injured or dead. This is a bigger problem. This is something called a sinkhole. It happened in a place called Guatemala. You see this? This small thing is a building, and this big sinkhole, it can take lots of buildings and take it inside the earth. People were sleeping in their homes, and suddenly they discovered that they are inside the bottom of the earth. God knows what happened to them. Is there a way to prevent this? Yes, there is a way to prevent this. Geology can prevent this, and geotechnical engineering based on geology can prevent this. We can study this and we can prevent this. If they knew that this type of this feature can happen at this place, they could have avoided building on top of it. We can know this. So it is very important. It's not just I go to the site, this is very good land, this is near to the city, this is, okay, I put my building here. No, I need to make some investigations before I put this. So to do the investigation, I have to be a geotechnical engineer. To understand the investigation, I have to be a good geologist. So I have to understand both. This is something similar in very prestigious places. This is in London Heathrow Airport. A sinkhole happened at this place. But why it happened? It happened because they were drilling a tunnel beneath the airport. So the action of the drilling caused some what do we call disturbance on top, and this disturbance resulted in this man-made sinkhole. This is in Germany, Munich. A bus fell in a sinkhole, also because of drilling a tunnel beneath it. This is a picture of something I took myself. I was working in this project. It was in Jordan. And in Jordan, they have the Dead Sea. The Dead Sea, they need to make ponds or lakes, small lakes, to evaporate the water. Of course, you know that why it is called the Dead Sea, because the amount of salt in the water is very high. It means that it is very good for industry. If I take this water, I evaporate the water, I will end up with lots of salt, and I can take the salt, send it to the factory, and select whatever type of salt I need, and this is very good thing, very good industry. So at this place they were doing something like dikes. A dike is like a small dam, just something to surround the water so that it would not go back to the Dead Sea. And I leave it for a while till it evaporates, and then I take the salt from it, the very high concentrated salt. Actually, this was the dike that was keeping the water behind it. There was a collapse in this dike, and this collapse resulted in something like a flood that happened at this location. We needed to do investigation at this location, and to carry this investigation, we had to move the equipment using a helicopter to go to this site, because it was very dangerous to walk, because it was the place where failure happened in the dike. So this is another example. This is a very good example. This is a building similar to the buildings at the behind. What happened to the building here? It fell as one piece. Why it fell as one piece? Because of the soil. At this location, this soil, due to the way they constructed the building, they did not take into consideration something. We are not going to go through it now. Maybe we can discuss it in next term, because it is not related to geology, it is related to geotechnical engineering. But because they did not take this into consideration, the building fell as one piece. What can we do with this building? We have to demolish it piece by piece and take it out of the site and rebuild it again. So it is maybe there were nobody was injured, but actually it is a big catastrophe for the project. It's a big loss for this project. Of course, you know this building in Alexandria. To 2017 in Alexandria, one building tilted till it reached the other building next to it. Why this happened? Because they did not study the soil. Can you see here what is here? Why this texture is different than this? Can anybody tell me? If you have two buildings next to each other and you need to cover the facade, what do you call it? عاوزين نبيض الواجهة. If you this facade, you need to cover it, and there is a building next to it. You cannot go inside to cover it. So what happened is that this building was having another building very close to it, both touching. But suddenly, this small building, they decided to remove this building. But what happened is that they did not take into consideration adequate foundation for this tall building, and this tall building was depending on the building next to it. It is as if you are very tired and you put your hand on maybe a small, he may be a child, but he is supporting you. Once this child go away, you are going to fall. This is what happened exactly. So this is a way. Okay, these are all examples of why we are studying geotechnical engineering and why we are studying geology. So how can we know what is beneath? We need to do some site investigation. Site investigation, I need to understand what is below the soil. I can go to the site, I can see the surface, but what is below, I don't know. And if I try to dig something with my hand or with the shovel, I will reach 1 meter or something. It's nothing. I need to reach 5, 10, 20, 50 meters, something like this. So how can I do this? I do two things. One thing called borehole. حد سمع عن جسات؟ You all heard about boreholes in Arabic. جسات. Gassat is a machine that it's not the machine, a machine that will go to the site. It will do this boreholes or gassat. It will drill a small hole, but this hole can go very deep into the ground. It may reach 100 meters. I can take samples from the ground even till 100 meters if I need. Also, there is another thing called test pit. Test pit is just, I take an equipment and backhoe or something. This equipment will dig a hole, but this hole will not reach more than 2-3 meters. So it is important if I am interested in the very top layer. But if I'm interested in the very deep layer, I need to use boreholes. I have to design this site investigation. How many boreholes? Where are these boreholes? Below the buildings or outside the buildings? By the way, do you know, by just guessing, where can I put my boreholes? Below the building or outside the building? Below the proposed building or outside the proposed building? If I'm going, this is the proposed building here, this one, and this one is another proposed building. Where can I put my boreholes? Is it correct to put a borehole here or here or here or what? As I said before, the soil may differ from one location to the other. Oh, I mean, I will do lots of borehole, but I will concentrate my boreholes below the building. And I may take 1 or 2 outside the building just for info, because outside the building I may have a pathway, I may have a small room, security, I may have other less important structures. So it means that I would concentrate my boreholes below my proposed building. How deep I go, this is not important for our geology course. This is a shape of the machine that is drilling for boreholes. This is the shape of the test pits. But this is a very deep test bit. By the way, this was taken by me in one of the projects that I worked for. It was in Sana'a. They have their a very good practice. They can drill very deep test pits. Do you see this yellow thing? This is the helmet of a person below. So it means that the depth of this test pit may reach 7-8 meters. Of course, here in Egypt or in any place, it would be very difficult to reach this by hand drilling. But there they have the talent to do this. There is another thing called seismic logging. Seismic logging is very important because it is related to our geology course. Seismic logging is like the sonar that you do when you have something wrong with your stomach and you go to the doctor, you tell you need to do an ultrasound. What is an ultrasound, or what we call sonar? He put an equipment on your stomach and another thing maybe, and then this equipment or this transmitter sends some waves and receive it from the other end, and they take these waves and analyze these waves to know what is inside. Now they can tell you for pregnant women, they can tell them you have a baby boy or a baby girl. So it is a very good way for understanding what we do not see by sending waves, receiving it back, and analyzing it. So this is the seismic logging, and we do it for Earth. Then we go to the lab and do some testing. If I do this test pit or the borehole, then I will take some samples. What I'm going to do with the sample, I'm going to send it to the lab. At the lab, I can do lots of tests. By the way, in this course, you will visit the lab to see the lab and to see maybe one or two tests to get acquainted with it that we are going to use mainly for our geotechnical course. Then we prepare geotechnical report. We are not going to discuss it this term. And to end our session, I always prefer to see this picture. Any one of you know what is this picture? Pisa Tower. Pisa Tower, we all know it because it is a very famous monument, but actually it is a catastrophe. It is a big mistake. They tried to build a building, a very important building, with inadequate investigation. They did not know what is below the ground. So what happened is that while they are building, this tower started to lean. They stopped. What is happening? They found that the leaning stopped. They decided to continue. They continued again till they reached the top. But once during reaching the top, the tower started to the leaning started to increase, and it is still increasing with time. And now they are trying to protect it, to keep it as it is, to save it as a monument, not to save it as a tower. So what I always say, always remember mistakes in geotechnical engineering or in geology are not always that lucky. So this is the end of our very short introduction. We can take a rest now.